We first log using our login and password. We also use the project ID in order to select on the server the one on which we are going to work on. There is a 2D view representing the world and its subsystems in yellow and the indicators in green for the moment. The main objective is to measure the resilience of the world against the traffic flow, that is to say, how disruptive events are absorbed by the world system in order to have an acceptable traffic flow. These 6 indicators are model elements in which data system will be integrated in order to monitor its resilience. The first one is occupancy rate, allowing to monitor the vehicle occupancy rate on the road. It receives data from a system data source, which is the occupancy rate measure system. The detected fire extension monitors if a fire extension currently happens on the road. This is done by the video stream processing system using machine learning. The detected person, detected vehicles, and detected fire use the same data source to respectively detect if some people, vehicles, and fire are on the road. The last indicator, measured air temperature, allows to assist to watch the dangerosity of a fire by monitoring the air temperature. The global resilience, that is to say, those of the road system, is displayed on the left of the 2D view and also on the chart on the bottom right. The received data, Fn, and the resilience for the occupancy rate indicator is also displayed on the left of the 2D view when the model element is selected, and also on the chart on the bottom left. On the left of the 2D view, we can also see other fields. For this example, we ignore Fmin and Fnmin. Fmax and Fnmax are the limits defined by a domain expert. Fnmax is the acceptable limit, degraded state of the infrastructure, and Fmax the maximum limit, state in which the infrastructure must quickly return to the previous state. Each indicator resilience is calculated according to Fn, Fnmax, and Fmax. If Fn is lower than Fnmax, the resilience is 1, optimal state, in green in the 2D view. If Fn is between Fmax and Fnmax, the resilience is then between 1 and 0, degraded state, in orange in the 2D view. And resilience goes to 0 when Fn is higher than Fmax, emergency state, in red in the 2D view. We also see the simulation file paths and the frequency fields on the left of the 2D view. They allow to simulate data from a data source at a defined frequency and by using a predefined CSV file. The object to detect field is used when the detection algorithm, which uses machine learning, needs to know which objects to detect. It is not the case for the occupancy rate and measure air temperature indicators, but for the other ones. Once we are connected, the prototype starts to run and we can observe on the top left the 2 data sources video stream for all the indicators, except in measure air temperature and occupancy rate, which are simulated. The system data evolution, that is to say data received regularly, for the latter, that is to say occupancy rate, are displayed on the top of the bottom left chart, while the resilience for this indicator is calculated and displayed in the same time on the bottom. We can also see the global resilience evolution in the bottom right chart. This resilience is calculated by multiplying the resiliences of all indicators. Considering all of this, we can now observe the continuous road system resilience monitoring, that is to say, how the traffic flow evolves when disruptive events happen, like a vehicle fire.